Hello, everybody. Good afternoon, and welcome to this new session. Today, we'll be talking about the cybersecurity, and we want to demonstrate how Wireshark and companion tools such as dissect can be used to analyze cybersecurity-oriented use cases. My name is Luca Deri, and I'm here with Matteo and Martin. The idea today is to split the talk in three parts. I will be talking about the first part, the packet inspection and cybersecurity. Matteo will show in the second part scripting, Lua scripting, and how to use them for cybersecurity. And finally, Martin will focus on industrial control systems and how cybersecurity is relevant for that environment. At the bottom of the slides, here you can see that I put a URL that contains the slides, those that you are currently watching, and some pickup files I will be using to demonstrate the feasibility and the power of Wireshark in cybersecurity. So let's start with the first part that is talking about stream-oriented traffic analysis. So in essence, here we'll be talking about the analysis of a single stream, as Wireshark calls it, and to understand what happens in terms of cybersecurity in that stream. So as many people here, or most of you are familiar with this concept. So in essence, a stream is whatever you can do with Wireshark when you click on a packet and you right click on follow, TCP stream, TLS stream, UDP stream, depending on what you're currently analyzing. So this is the idea. Now, why cybersecurity? We believe that this is a very popular topic today. Wireshark is popular, but cybersecurity is also popular. And with Wireshark, if you search Wireshark and cybersecurity on Google, you will see that many people are using this tool to search for problems, for security problems, to find issues, to diagnose attacks. However,
sorry, Luca. Do
yes,
you share a screen?
Yes, I do.
We don't see it.
Really? Let me start again. Yeah. Yeah, should see it, right?
That's okay. Yep. Thanks.
Okay, let me go back. Okay, now you can see it. Yes. So in essence, Wireshark and cybersecurity are very popular topics. So we would like to simplify our approach to cybersecurity because not everybody is an expert, but most of us need to understand the security accidents. And this topic is also very popular at the Sharkfest. So if we go back and look at the past few editions, you will see that people are talking about that. In particular, there is a very nice website that I recommend, Malware Traffic Analysis, that contains several traces that are constantly updated with new malware, new issues. So in essence, this is something that everybody knows and that we would like to simplify. Because the main challenges is that understanding security is not that simple for everybody, because there are many techniques, there are many malware, and there are many issues that need to be known to the user in order to understand what's happening. And analyzing a cybersecurity accident is something very complicated. So we would like to create something that allows normal Wireshark users that have some knowledge of the network, some knowledge of packets, of course, to have a simpler life by simplifying how he can analyze traces. Now, if I look at the theory and I see how the cybersecurity is approached in terms of network cybersecurity, we see there are mostly two families. There is NIDS and IPS. NIDS is Network Intrusion Detection System, but it is basically a system that allows to monitor the traffic and report violation when the traffic does not meet the expectation. So in essence, when something is not working as expected. The IPS is similar to NIDS, but the main difference is that the NIDS is simply looking at the traffic, whereas the IPS, it is blocking those traffic flows that are considered bad in terms of cybersecurity. Because Wireshark is about network monitoring, so I consider that Wireshark will fall in the first category, in the IDS category. So in essence, today we'll be talking how to extend Wireshark with some IDS-like features. And how to do that? So there are basically two possibilities here. The first one is signature-based detection. So it means that whenever there is a security accident, if we know from some past knowledge that this problem happened because somebody did something bad in a certain form. So for instance, contact a certain host on a certain port, and the content of the payload was this. This is called signature-based. Other tools instead use anomaly-based. So in essence, they look at good traffic, and whenever something goes wrong, they realize that this new traffic doesn't look as the good one. So therefore, they compute a delta, and in essence, they say, okay, there is something wrong happening. This is more general. However, the first one is probably more focused on a problem. Just to give you an example of how an IDS signature base works. This is a security rule of Suricat. Suricat is not basically equivalent term of configuration. As you can see here in this rule, we have to specify the IP addresses, that in this case is any, the port, and the content or the protocol. So this means that if an intruder changes the port, so doesn't use 443 or 465, I use 4443, then this rule is basically useless. So that's why we said, if we have to extend Wireshark, we probably have to do something that takes care of this problem and does not load into Wireshark 1,000 and 1,000 rules like those that I put here on this URL from Emerging Threats. Now, in 2017, at the Sharkfest Europe, I talked about NDPI. So that is basically a deep packet inspection library, open source, that we develop at Tento. And today I want to update you about that and to show you how this can be used in cybersecurity. So in essence, the idea is to give you a follow-up of that and to show you how this library can help you understand the cybersecurity accident and complement what is currently happening with Wireshark that when it comes out of the box. Therefore, the idea is to extend Wireshark with stream-oriented traffic analysis. So this means that with this library, we'll be monitoring each stream, okay? So there is no relationship across stream. For instance, in the second part of this talk, Matteo will be talking about scanning, for instance. In the case of the scan, so each individual flow is good, okay? Probably there are some issues that we are talking with a closed port, but that's not the problem. The point is that a certain host is sending many streams more or less at the same time towards multiple hosts or toward multiple ports of one host. And this is something that we'll talk in the second part of the discussion. So therefore, we want to extend what Wireshark is doing by adding some sort of deep packet inspection into Wireshark. This is the idea. So therefore, we want to add the ability to observe security issues that are not available with the standard Wireshark, because Wireshark is focusing on the packet level. So for instance, retransmission, packet out of order, this type of things. Instead, for cybersecurity, we need to do some sort of, let's say, different analysis, okay, on top of this analysis that is already part of Wireshark. So this is the idea. Now, how does it work? In essence, in Wireshark, you can use a dissector of a protocol by setting a port of a protocol and say, okay, in this port, there is this protocol. In the packet inspection, instead, we don't have to set anything. We probably start from the port that is more likely to match. So in case you have a TCP port 80, probably we'll start checking if this is HTTP. But in general, there is not this need, because with DPI, we are able to find every protocol on every port. And second, with this deep packet inspection library called NDPI that we developed that is open source, we are able to detect applications that are not designed to be recognized by Wireshark. So for instance, I will show you a demo very soon that is talking about NIDS, that is a popular screen sharing application. So this means that while Wireshark is focusing on a certain aspect of the protocol or of the packet, here we are talking about something different, more at the application level. How does this fit into Wireshark? So as you know, Wireshark can be extended through some plugins called Xcap. So in essence, you can have a virtual interface here that in our case is called NDPI. And this virtual interface allows you to analyze those packets and to extend what is known to Wireshark from the internal packet representation with something else. So it means that you can complement the existing packet analysis features part of Wireshark with some cybersecurity-oriented features that will be provided by NDPI. So therefore, our idea is to mix these two things, to extend what is existing, and then to provide a tool that allows you to drive it towards a security accident analysis in a simple way, without having to go through very long pickup files that are hard to understand, in particular when you are analyzing a network that you don't know, and where it is complicated to find the issues in a very simple way. In particular, what it is adding to Wireshark. For instance, one of the main features is the ability to understand DJs, so domain generated algorithm, so that those domain names that are generated automatically by some applications. So usually they're very long, they contain letters and numbers that are not really meaningful to a human. And then to associate a risk with the problem, and that the risk represents what's wrong with this traffic. In particular, at the moment, we support over 32 risks. This is one list that is part of NDPI, that they are part of this extension that we have put in Wireshark. So it means, for instance, that if you have a self-signed certificate, or if you are talking with a server that is as an obsolete version of SSH, this will be reported as a risk. And how do we map risk to a cybersecurity problem? Or how do we drive the user, the security analyst, towards the problem? We do that adding something called score. So it means that there is a numerical value that is associated with the risk that tells you how bad is the problem that we have found. So for instance, if you have an HTTP request with a numeric IP, this is not that bad. It is much worse to see, for instance, a DJ, just to make an example. So therefore, a score is a numerical value from 0, no problem, to 255, severe problem, that we associate with the flow. And then that NDPI is passing to Wireshark. And this allows you to consolidate, for instance, this problem at the network interface level, at the pickup level, or for instance, at the host level. So because if you have many hosts that have many streams with issues with high score, so it means that this is a problem. It means that this host is more important to another in terms of cybersecurity, that you should start probably the analysis from this host instead of other hosts that look good from this point of view. Let's now show you a demo. Okay, let me change the screen and show you the desktop. Okay. This is Wireshark. I think everybody is popular. It's a popular topic. Is familiar with that. So as you can see, here we have installed a new Xcap extension called NDPI. Again, I put on the chat the URL of our presentation, some pickups that drive you towards the GitHub page of the software. But if you have questions about installing and using it, we can talk later on Discord. So in essence, here you will see this extension. You click on it, and it allows you to see a live capture or a pickup. So let's find a pickup. Let's take a pickup. Let's take, for instance, AnyDesk. That is a popular screen sharing application. When I click Start, in essence, the pickup is analyzed by Wireshark through this extension. And as you can see, we populate a new column called Protocol. Okay, so here instead of having the standard protocol, we complement this with additional information. In this case, TLS AnyDesk. Now, if you look at the packet, so let's enlarge it for a second, you will see that this TLS stream is on port 80. That is very unusual. And also, this means that Wireshark will have problems detecting it unless you go and say follow TCP stream or you specify the port 80, that in this case of 43535. That is TLS, and that is not designed for HTTP. because in this case on port 80 we see a TLS stream. And NDPI gives you other information in addition to the protocol, gives you, for instance, a flow risk that in essence is a bitmap. Okay, as you can see, there is a bit set to 1. Okay, that means non-protocol on a standard port. So in this case, on port 80, I expect to see HTTP, but I see TLS, and TLS was not on port 443. And also here, from the analysis of the TLS, we see that this TLS is not carrying HTTPS. That is kind of normal because here we are sharing the screen. So in essence, we associate a risk with this protocol, and with this risk we give a score, okay, based on that. So with the standard interface of Wireshark, here you can see, for instance, there are some new menus, okay, and the last one is NDPI flow score. In this case, we show you that these are the flows that generate the problem, okay, and we see also the score associated with the problem. But in addition to that, you can have other type of filters. So for instance, here, in addition to the standard filters that you have, you can also do something like this. It's a NDPI flow score greater than 0, so that Wireshark can select in this trace, all those flows that for one reason or another, they're special, okay? And we specify that there is a problem, and here we specify also the score and the problem itself. Let me show you another example. Again, click on NDPI. Let's take another pickup. Of course, you can do this with live traffic, okay? Let's take this one, okay? This one, it's another small pickup taken from malware traffic analysis. So in this case, we have HTTP traffic, okay? So let's have a look at the flow score here. So we see that there is a problem with this flow, okay? It's a very high score, 260. So this port 49.7. So we do TCP.port equal, and we do the filtering. Let's see what's happening with this flow. Let's say follow HTTP stream. Okay, as you can see, we have found a problem. The problem is the following. This is HTTP, looks good. This is an image, as you can see. Okay, so we request an image. This is an image, but unfortunately, this is a binary application. So NDPI has detected that instead of downloading an image, here we are downloading an executable, and this is usually a problem because the problem is that when this happens, usually there is something wrong happening. So if I go at the risk, you will see binary application transfer, that this as the main problem. And also you see that there is a numerical IP address, because in the HTTP request, so instead of requesting a symbolic name, we do on HTTP a request for a numeric name. So this is how NDPI works. So in essence, it is possible with NDPI to associate risks with a flow, and it is able to understand what flows have problems. And then with the extension that we have created, again, that are open source and part of NDPI, it is able to understand what is happening and to report you exactly the flow score. Now, just to complete this presentation, I want to tell you the last thing before we move to Matteo. We very much like Wireshark. We love Lua because it's a simple scripting language. But unfortunately, if we have to run or write complicated programs outside of Wireshark, probably the best option at the moment is to use PyShark. Well, if you're interested in Lua and if you like Wireshark, you should also look into our distribution, because we have created also something else that allows you to manipulate, similar to what PyShark is doing, packets using Lua. And this is yet another contribution that we have done to Wireshark. Okay, Matteo, I'll let you take over the screen.
Yes.
Talk about the second part.
All right. Hello, everyone. I'm Matteo Biscosi, and today, like Luca introduced before, I'm going to talk about how it is possible to develop cybersecurity scripts in Wireshark. Because a problem of Wireshark is that it is going just to analyze the packets. So you are going just to extract information from them. But you are not going to have information about the flows inside the pickup or real-time traffic. So instead, you can do that using developing a Lua script in Wireshark. Like Luca told before, Lua is a really simple programming language, and it is really lightweight. You can do a lot of things with Lua, just like writing dissector, taps, and so on. But at the same time, you cannot do really complicated things. However, it is really good for our purposes because you can filter all the traffics, packets, and all the things we are going to capture using Wireshark filters. So for instance, if you want to analyze TCP traffic, you can just do it by adding a new filter for the TCP protocol, and then you have all the traffic you want. So Lua scripting in Wireshark is really good to analyze flows and host traffic to detect possible attacks, problem inside the networks, and so on. Just to show you some example of cybersecurity scripts you can develop in Wireshark, I personally developed 4 scripts. The first 2 scripts, the HTTP and DNS request reply ratio, are not really cybersecurity scripts, but they are really good scripts to understand if there is a problem with a network or with a server. Then I developed a TCP No Data Exchanged that it is it could have a lot of possibility or a lot of attacks and so on. And instead, I developed a particular TCP No Data Exchanged that is the SYN Scan attack, the port scanning attack. So before taking a look at how it is possible to develop a Lua script in Wireshark, we have to set up some few things. First of all, we have to enable a variable into the configuration file of Wireshark, file called init.lua. As you can see in the screenshot below, the first variable, the enable.lua, must be equals to true. Then you can run Wireshark. You can run Lua scripts in Wireshark just by adding the -x Lua_script option. And then you are going to have your script in Wireshark. An important thing about the Lua scripts is that the Lua code is executed just after all these sectors, but before reading any file. So let's taking a look at how it is possible to develop a Lua script in Wireshark. First of all, you have to register the menu entry. In this way, you are able to click on your script and run it. I'll show you it later with a brief demo. Then you have to create a window. The window is used to draw the results. And then you need a listener. So a listener instead is used to capture packet. Then you are going to analyze each packet using a specific function called .packet. And then you are going to draw your results. So, like I said, you can see, for example, the packet function that is going to be called for each single packet. From that, you are going to extract all the information you are interested about and calculate your results and draw your conclusion about the traffic. Then you have the function to draw the result into the window. An important thing is that you have to clear the window before drawing again. And below you can see the register_menu function I was talking about before. In this case, for example, I created a menu entry called Wireshark and a submenu with all my scripts. Another important thing to know about how it is possible to develop these scripts is that you need some cleanup functions. For instance, for example, if you do not remove the listener, then it is going to run indefinitely. So you need to remove it, just like in the screenshot. You need, for example, the reset function to when you reload a capture file, and to ensure that all the packets are processed, you need instead the tap.packet function. Now let's take a look at the scripts I developed. First of all, we have the HTTP and DNS request regularization. They are really important scripts because usually in HTTP and DNS protocol, you have one request and then one reply. So if the ratio is different from one, then it means that there could be some serious problem. There could be problems with the server, so the server could be under some type of attacks, or it could be just crashed or down, so they could be really serious problems. Instead, it could be even that the network itself is congested, and for example, the server is going to receive just one request after 10 or 20, and so on. So they are really good to understand if there is a problem with the network or with the server itself. The third script I developed is the TCP No Data Exchanged. Now, like I told you before, it is a really important script because usually a TCP flow should have some data. So if no data is exchanged in a TCP flow, for data we are talking about data going on from layer 4 of ISO-OSI upwards, then there could be some serious problem with the flow. Two of the most known type of problems we can have are the TCP SYN Scan and the TCP SYN Flood, for example. In fact, here we have the fourth script, the TCP SYN Scan. The TCP SYN Scan is one of the most common type of port scanning because it is really easy to develop. And it is really a lightweight script, port scanning, because it is going just to use the three-way handshake of the TCP protocol to understand if there is some service running on a port or not. To do that, it is going to use the first two request and reply of three-way handshake. So it is going to send packets with the SYN flag marked, and then it is going to await for the reply. If the reply is a REST or ACK, then this means that there is nothing running on that port. Instead, if the server is going to reply with a SYN ACK response, it means that the service is running there. So now let's do a brief demo about these few scripts. As you can see, I choose to pick up to show you those 4 scripts. Let's start with this one. Like I told you before, this is here you can find all the scripts you developed. So just go into tools, and there you are going to find the entries you added with the register menu. Here I have the Sharkfest and then the DNS HTTP TCP scripts. First of all, let's analyze this pickup with the DNS request declaration. Now it is going to analyze all the packets. Just wait a few seconds to analyze all the traffic. And here you have the results. So as you can see, we found in total 3 DNS flow, and 2 of them have a ratio different from 1. Now, this ratio is really close to 1, so it could be all right. But here we have, for instance, a problem. We have a flow, a DNS flow with 0 requests and 3 replies. Like I said before, a DNS should have DNS protocol should have 1 request and 1 replies. Instead, here we have a request, 0 requests and 3 replies. Now instead, let's take a look at the HTTP request declaration. And here instead, you are going to see a lot more problems. Let's wait a few seconds before. All right, here we have. And as you can see, we have 48 HTTP flows with 17 of them with a ratio different from 1. As you can see, we have, first of all these, or most of these flows with a ratio different from 1 are from the same host. And as you can see, we have a ratio really strange because we have, for example, a ratio of 3 with 3 requests and 1 replies, a ratio of 0.3, or here we have a ratio of 2.5 with 20 requests and just 8 replies. So as you can see, this could be a really important problem. Now instead, let's see if we can find some other problem with the TCP No Data Exchange. All right. Now, as I said before, there are a lot of problems. With 281 TCP flows, we found 86 of them with no data exchanged. And all of them are from the same host, from different port to another host with port 80, for instance, or 443, and so on. As you can see, all of them are from the same host and from a different source port. Now instead, let's take a look at the last script. I'm going to choose another pickup. This is a pickup I got from a SYN Scan, just to show you an example. And here we have the TCP SYN Scan script. As you can see, there are a total of 2 flows, and one of them has a total of 1,000 flows with the same host, the same source IP, and the same destination IP with just different source IP. As you can see, you can easily find SYN Scan using this script. And that's all. Thanks for listening. Martin, you can share your screen.
Yes, thank you, Matteo. Share. And let's start from here. So we have the third part of our joint talk is cybersecurity in industrial control system, and I'm going to show you how you can use Wireshark for helping you to identify problems in industrial networks. So maybe the question why we do monitoring. Of course, as you know, we have performance issues can be a problem. Then all the stuff which do not belong there, like malware or just somebody scanning ports, as we just heard before. Then, of course, we want to know that if we have a redundant network, that everything is working fine. And the last point is configuration errors. That is meant not directly to the network itself, but the industrial protocols running on the network. So if we look at characteristics of industrial network data, we have some differences to normal normal traffic like you're maybe used from office environment. So we can have very long flows. They can go over days. This is due to the protocol implementation of industrial protocols. There, like every packet is having some information or is doing something on the industrial system, and just as it is, these flows live very long time. And another maybe difficulty is that protocol implementation, even if the protocol is standardized, still vendors or even system integrators adapt part of the protocol. So this makes it very hard to track problems, or even if you want to set up monitoring, you have to adapt your monitoring to your system which you want to monitor. Then also, similar to what Matteo said with TCP payload 0, in industrial networks, the payload is almost 0. There are some 50 kilobyte, maybe sometimes 200, but the good put is typically below 50%. So if you have some measures in place, like performance measurement, then you will see a difference when you start to monitor industrial network traffic. So now cybersecurity. Cybersecurity starts with baselining. I need to know what is going on in my network, like how does normal look like? And that can be very difficult because this type of networks, they they grow over time. Then there comes a machine which is added, other machine, another site. So is growing over time, and it's very difficult to do the baselining, or you can also say it's hard work to figure out what is what on your network and assign it in your inventory, so you know what is going on. And Wireshark can help a lot at the end, when you need to look at the packets, you can figure out what is going on. So today I want to look at the industrial protocol, this IEC 608.75.104. It's a very old protocol. It used to run over a serial 2-wire bus, and it was then transferred or ported into TCP IP communication. So this means, like, inside the TCP packet, you have like other communication. So this protocol, IEC 104, I call it short, has like also keep alive or checksum or like basically same what you know from TCP, just encapsulated in the payload. It is widely used in the energy distribution, but also water, wastewater processing, and is based on TCP IP. For colleagues in the US, you might be familiar with DNP3, which is very similar to the 104 protocol. Luckily, Wireshark is already dissecting the protocol, and you can see all the information which you need to know out of the standard Wireshark installation. But as I said, normally the installations, they are vendor or site specific, so sometimes you need to add something more. And for that, we have a short look how the protocol is built up. So you have the payload. In the payload, you have this APDU object with some control fields, the length. Then as a payload of the APDU is the ASDU. There inside, then at the end is the measurement data, for example, the current frequency of the voltage itself, power used, and so on. That looks very straightforward. Promise, if you go one deeper, you can have in one TCP payload multiple APDUs, and in one APDU you can have multiple ASDUs. So this means if you start to dissect or look at this data, you need to loop through the data. You cannot really work with signatures, as almost every packet looks different than the other one. So now why we do that with Wireshark, or at the end why we choose the Lua plugin. This is most of the operators who work with these machines. They are not network specialists. They can use Wireshark. They can of course open a PCAP, have a look at it. But to enter some filter parameters, that is for most is out of their ability. So with a plugin, we can help them to like identify problems inside the protocol. And as said already before, with Lua script is easy to deploy. Like it just to the standard Wireshark, I have to load the Lua script into the right directory, and I'm ready to use it. Further, if I develop an algorithm inside the Lua script, I can even use it for my network monitoring. You know, when I want to have special use cases where I need to monitor something specially. So if we look at the Wireshark, how does it look like? You might be familiar with the expert view. So just there we add this 104 analysis where we can highlight some problems in the configuration. This example is a packet you see where it contains a time stamp in the packet itself. As in the electrical energy distribution, time is very important, but we see that this time is it has a difference to the epoch time of the packet, which is quite large here, 13 hours, or it might even be more. But you know, is the time difference is more than 3 hours, so there is a configuration problem in the industrial device. So with that, you know, the operator can go back to this device and adjust the settings so that the time inside the device is correct. Also, as the protocol said, is some implementations sometimes maybe not 100% correct. Wireshark, as you see on the right here, is using the square brackets to show that Wireshark interpreted an information which actually is not in the packet. You see on the left, this IOA with the 78 at the end is 3 bytes in the packet, But on the right, I have also IOA, which is mandatory for this field, but there is no byte assigned in the hex code. I mean the hex field below. So Wireshark correctly interpreted how it should be, but is missing inside the packet. So also this could be a problem in the configuration of the device, or just that they interpreted it, the integrators in certain way, and somehow the information is not there. Then a third use case is like inside this IEC 104, you have, they call it type IDs. These are basically commands how you can, for example, request a measurement value from a device, or you can send a command to the device like open a circuit breaker, close it. And normally on the site, you have a certain amount of type IDs or a set of type IDs which are allowed, and other type IDs are not allowed. And with this analysis, we can show to the operator the not allowed type IDs. So again, he can go back to the device and adjust accordingly. This came out of the Ukraine incident some years back, where the Ukraine power grid was shut down by a cyber attack, and there they used some type IDs which were not seen before to open the circuit breakers. So, but again, baselining is very important. So I need first to clean up my network before then I can start with the security monitoring and detect some anomalies. That is the part for the Lua script. Also, what we use is the PyShark together with T-Shark. Also here, we can, when we run over a long time, we run some measurement with the PyShark. We can very handy extract some protocol fields we want to analyze further, or just to track some measurement, how it looks over time. We also can replace MAC IP address by an ID. For example, when you want to share data for privacy or other restrictions you might have to share data. So this you can do easily with this PyShark script. Also, of course, you can adapt the script according to your different protocols and site-specific configurations. I use it to export to a CSV file, and then just as a look, a screenshot how that looks like, so you have an idea what you can do. And I think, as Luca mentioned already, you can find all code on GitHub, and have a look, or implement your solution, develop it further according to your needs. Thank you everyone for listening, and have a great afternoon.